Welcome to this presentation on cognitive work analysis. This presentation has been developed with human factors practitioners in mind. However, it's still of use to those who are just seeking to get a better understanding of what cognitive work analysis is. The presentation will be split over 3 YouTube videos. The first video will cover the introduction of what cognitive work analysis is. The second video will cover a real-world example about how the technique or framework has been applied in the past. And the final video will cover a little bit more about how it can be applied in real-world settings and some of the value it adds. That video will end with some signposts in terms of where you can get further information and assistance if you choose to develop a project with cognitive work analysis in the future. The presentation in its entirety will be looking at what cognitive work analysis is, what it can be used for, when it may be a good idea to use it, and when it probably isn't. Like many things, our lives are a lot easier if we apply the right tool for the right job. There's not simply one tool to fit one project. However, if we pick the right tool, we can often save ourselves a lot of time, effort, and end up with a more slicker and more usable result. So what's CWA the right tool for? Well, cognitive work analysis has been developed specifically for complex socio-technical systems. By this, we're really talking about systems that have both human and technical components working together to achieve a common aim. By complex, we're really talking about systems with a high risk, in that when something goes wrong, it's extremely undesirable. They're dynamic in that they're constantly changing in a non-deterministic way, such that it's almost impossible to predict what's going to happen next. There's lots of uncertainty in the fact that no one in the system really has a full picture about what's going on and at all stages of the system. And finally, there's lots of numerous interconnected parts, and these interconnections are very difficult to model. So by example, I've put some photos up here that represent some of the projects I've worked on and applied cognitive work analysis to in the past. There's examples here such as helicopter mission planning, training for Merlin helicopters, maintenance studies on the Typhoon aircraft, tank decision making, command and control studies, and the investigation over the introduction of new technology and communications, the redesign of a manoeuvre room for a nuclear submarine, various driving studies, and some studies on gas and electricity distribution. So let's set the scene a little bit so we can understand a little bit more what cognitive work analysis is for. Here we have an example where, as a human factors practitioner, we're called into a problem where a system isn't quite working the way that the designers would hope. We have an operator and we have a piece of equipment. In this case, we've used a computer to illustrate some kind of technology. The type of technology is fairly unimportant. So as we turn up, we can look at this and dip into our human factors practitioner's tool bag, and we can pull out a tool such as, and try and fix the individual. So pulling out a tool like a training needs analysis, we can look to change the operator in terms of their knowledge, skills and attitude so that they're better equipped to be able to interact with this piece of equipment. They have the understanding, the knowledge and the attitude to work well with it. However, if we look at a lot of human factors literature, and especially on things like websites and almost human factors propaganda, we see that human factors is not about fixing the man to the machine, it's about fixing the machine to the man. So we can look at things like task analysis, and we can change the machine or the technology, and we can start thinking about how the task was done in the past and how the technology can be changed so that it better maps what the human's trying to achieve. A third approach is to kind of jointly optimize this human and machine together, often called human-machine interaction or human-computer interaction. This approach looks at the space between the human and the man and looks at optimizing their performance looking at the interaction and the points where the two need to interface. So in simple deterministic settings, these three approaches might be appropriate. They allow us to make small incremental changes to a system that's fairly static and have an improvement. However, in complex socio-technical systems, these approaches may not be big enough to really handle the underlying problem. Some of these problems may be that it's the wrong system to meet the purpose in the first place, the wrong piece of the kit's been assigned, the wrong agents, or the wrong organisational structure. So let's look at this graphically. Here we have a graphical representation of the previous slides. In the centre we have the individual, and we can see that the individual can be optimised by training design and workload assessments, and we have the component, and by changing the component we can also optimise the system. But outside that and the link between the two, we can see that by things like usability assessments, workstation design, task design and interaction design, we could optimise this human-machine subsystem. However, as I said, in complex socio-technical systems, these systems rarely operate in isolation. They're required to interface with other human beings in the team and also other pieces of equipment. Therefore, the analysis is often benefited if we extend it to think about things like communication and cooperation analysis, layout design, job design, and team design. In larger complex socio-technical systems, it's often important to start thinking about the organisation, such as a much larger team that may be distributed across different sites or even countries. Here we need to start thinking about allocation of function, who's going to be doing what, the organisational design, how things are going to be structured, coordination analysis, and environment design. Finally, we can go one step further and we can start thinking about the domain in which this organisation sits. Here we can start thinking about the function analysis and ask fundamental questions about what the system should be doing in the first place, how we can assess it, how we can optimise it, and how we can ensure safety and reduce risk from the entire system. So these points in this diagram have been organised around 4 corners, and these cover the 4 elements of the way we need to think about these systems, in that the structure of the system in terms of the organisation, the functional structure as what the system should be doing, the physical structure about how it should be laid out, and the social about how the system should be communicated between. Cognitive work analysis is fairly uniquely placed to study these complex systems. It does this by focusing on the constraints on how a system can perform. Other human factors approaches focus much more on describing what's actually happening in a system or prescribing what should happen within a system. By focusing on the constraints, there's a focus on the realms of possibility. The framework is broken down over 5 phases. And again, each of these 5 phases describes a different constraint set. Starting at the top with work domain analysis, the constraints within the domain are described independent of activity. At the next level down, we start to describe how the constraints imposed by time and location. We then look at the constraints that shape how activity can be achieved, who can do what, and finally, the skills required. So returning to the diagram we saw just a few slides ago, we see that starting on the outside at the domain level, work domain analysis allows us to describe the system at this outer level. And moving into the centre, we see that things like worker competency analysis allow us to describe the constraints affecting the individual at the centre of the diagram. Not only this, but the other phases in the diagram and the CWA framework allow us to describe the system at a functional level, a physical level, a social level, and at a structural level. The next part in this 3-part series, we'll look at an example of how cognitive work analysis has been applied to a real-world setting, and hopefully by seeing it being applied, all this will become a little bit clearer.